Your model isn't done the moment .fit finishes running.
It's done when its hyperparameters are actually tuned. Last episode we trained XGBoost with whatever defaults it shipped with.
Today we tune that exact model 3 different ways.
GridSearchCV checks every combination. RandomizedSearchCV samples smartly. Same search budget, same model, same dataset, very different results.
Default, 80%. Randomized search, 80.4.
This is episode 15, Hyperparameter Tuning Explained. Let's separate two words people mix up constantly. A parameter is learned from data, weights, split thresholds, tree structure.
A hyperparameter is set before training even starts.
Learning_rate, max_depth, n_estimators, you choose those, not the data. Tuning means searching for the hyperparameter values that generalize best. GridSearchCV is the brute force option, and that's exactly the point. You define a grid of values for each hyperparameter.
It trains and cross-validates every single combination in that grid. 3 values times 3 values times 3 values, 27 models. Guaranteed to find the best combo in your grid. Guaranteed to be slow. RandomizedSearchCV flips the strategy entirely. Instead of a grid, you give it a distribution to sample from. Picks n_iter random combinations, you choose the budget directly.
Same 27 fits as the grid, but from a much wider space. It can try learning rates and depths the grid never even considered.
Here's the counterintuitive part. Random search usually wins.
Most hyperparameters matter a little. A few matter a lot. Grid search spends equal effort on every dimension, important or not.
Random search covers the important dimensions more densely by chance.
Bergstra and Benjo proved this back in 2012. It still holds today. The Bayesian optimization goes one step further than both. It builds a model of the search itself, which regions look promising.
Each new trial is chosen using everything learned from previous trials.
Optuna is the go-to library, a study and objective function done.
Fewer trials needed to reach the same or better result.
So which one should you actually reach for? Tiny search space, few hyperparameters. GridSearchCV is fine, even simple.
Large space, limited time budget. RandomizedSearchCV almost always.
Expensive models want the fewest trials possible, Optuna.
In practice, random search first, Optuna to refine the best region.
You don't need to tune everything. Start with what actually moves the needle. Learning_rate and n_estimators together, they trade off directly.
Max_depth controls how complex each individual tree gets.
Subsample and callsample_by tree, add randomness, fight overfitting.
Tune those 4 first. Everything else is fine-tuning after.
In code, both searches share the exact same interface.
From sklern.model_selection import GridSearchCV, RandomizedSearchCV.
Pass the model, the perm grid or distribution, and CV equals 5. .fit runs the whole search. Best_estimator_ holds the winner. Real demo. Same XGBoost, same noisy dataset as episode 14. Default parameters, straight out of the box, 80%. GridSearchCV, 27 combinations, 5-fold, 78.3. RandomizedSearchCV, same 27 fits, wider space.
80.4% the winner, and it beat the grid clearly.
Notice the grid actually did worse than doing nothing. That's a real risk. Every search object stores best_perms_ after fitting, no extra work. Grid landed on a shallow, conservative combo, max depth 3.
Random search found something the grid never could, max depth 8.
That combination simply wasn't a point on the grid at all. Let's lock in what we covered.
Hyperparameters are set before training. Parameters are learned from data.
GridSearchCV, exhaustive, guaranteed, slow.
RandomizedSearchCV, sampled, fast.
Random search usually wins at scale. Optuna refines it even further.
Tune learning_rate, n_estimators, max_depth, and subsample first. If that grid versus random comparison clicked for you, subscribe.
Quick look at where we are. Gradient boosting, then hyperparameter tuning, now those two are done.
Episode 16 goes to model evaluation metrics, precision, recall ROCAUC.
You just tuned a model. Next episode, you'll judge it properly. Episode 16, Model Evaluation Metrics Explained.
Accuracy, precision, recall, F1 score, and the ROC curve.
We'll evaluate the tuned model from this episode properly. Subscribe.
Your challenge task for this episode.
Train a default XGB classifier, then tune it with GridSearchCV. Then tune it again with RandomizedSearchCV, same fit budget.
Compare test accuracy and total search time for all three.
Bonus. Print best_params_ from both search methods.
Did RandomizedSearchCV beat your GridSearchCV? By how much?
Full solution is in the repo, try it before you peek. Default parameters, 80%.
RandomizedSearchCV, searching a wider space for the same budget, 80.4.
Episode 16, Model Evaluation Metrics Explained, drops next. Subscribe. Comment with your GridSearchCV versus RandomizedSearchCV numbers.
I'm Majas. This is CodeToAGI. Let's build.